A DeepSeek employee just dropped a groundbreaking open-source AI engine, and it's shaking up the entire industry. It's called NanoVLM, and get this. It's written in just 1,200 lines of clean Python code. No bloated frameworks, no black box complexity, just raw, stripped-down performance that rivals industry giants like VLLM. Despite its tiny size, NanoVLM delivers blazing speed, even outperforming VLLM by 5% in real benchmarks, all while running on a modest RTX 470 with 8 GB VRAM. Developers are calling it a cheat code for understanding how large language models work. And the best part? It's so simple and well-structured that anyone can read, learn from, and build on top of it. This isn't just an AI tool, it's a movement toward transparency, efficiency, and open-source innovation. A DeepSeek developer has quietly launched a side project that's making major waves in the AI community. It's called NanoVLM, and it's a brand new open-source engine that's stunningly compact, just 1,200 lines of Python. But don't let its size fool you. NanoVLM is built for speed and clarity. Unlike the bloated frameworks and complex code bases you usually find in AI tools, this project strips everything down to the essentials. It's fast, clean, and runs powerful large language models even on modest hardware, like a basic laptop GPU. What makes it even more incredible is that this wasn't some corporate initiative. It was built entirely in the developer's spare time, and it doesn't just rival production engines like VLLM, it actually reveals how they work step by step. Developers are calling it more than a tool. It's a guided tour through the brain of a language model, offering transparency and insight that's almost impossible to get from traditional AI systems. NanoVLM tackles one of the biggest bottlenecks in language models, inference speed. When you input text, the model breaks it down into tokens, processes each through multiple mathematical layers, and finally predicts the next word. Traditional systems like VLLM boost this flow by keeping GPUs constantly busy through complex scheduling, but their code bases are deeply layered and often unreadable. NanoVLM flips that model on its head. Its components are written in plain, modern Python with clear, logical structure. You can follow every operation from input to output without diving through chains of function calls or low-level modules. It's not only accessible but also educational, perfect for developers or students eager to understand how LLMs function internally. In terms of performance, NanoVLM doesn't just keep up, it excels. In a benchmark test using an RTX 470 with 8 GB VRAM, both NanoVLM and VLLM were given 256 unique prompts. The results? NanoVLM generated nearly 134,000 tokens faster, finishing in 93.41 seconds versus VLLM's 98.37. That's a 5% speed boost, achieved with far less code and no advanced hardware. The secret lies in clever optimizations, a prefix cache to reuse repetitive inputs, tensor parallelism to split tasks across GPUs, Torch Compile to batch operations for smoother execution, and CUDA graph capturing to replay processes with minimal CPU chatter. These are high-level production tricks, yet NanoVLM implements them clearly and cleanly. By making every trick visible and understandable, this tool lowers the barrier for anyone wanting to build, experiment, or learn. It's not just lean, it's a blueprint for fast, transparent AI development. Beyond speed and simplicity, what truly sets NanoVLM apart is its potential to transform how developers and learners interact with AI infrastructure. Unlike bloated engines designed for commercial-scale traffic, NanoVLM focuses on transparency and hands-on experimentation. It's not built for high-demand public chatbots, but rather for single-user jobs, such as data annotation, academic research, and personal AI applications. Installation is remarkably simple, requiring just a single terminal command. Once downloaded, users can load their preferred model, tweak parameters like response length or creativity, and run prompts with ease. If you're already familiar with VLLM, switching over is seamless thanks to its interface compatibility. Despite using just 8 GB of VRAM, NanoVLM matches the output of more complex systems while consuming fewer resources. This level of hardware efficiency opens the door for hobbyists and indie developers to run powerful models without enterprise-grade equipment. It's already being tested with larger models and multi-GPU setups to explore its upper limits. One standout feature is its eager mode toggle. This allows the program to execute tasks step by step, perfect for debugging or educational purposes. Once optimized, users can activate PyTorch's performance boosts for real-time execution without needing to rewrite anything. NanoVLM's educational value is also catching attention. In classrooms, students can actually study the inner workings of LLMs, how they tokenize input, manage memory, and craft output. These lessons directly transfer to industry frameworks like PyTorch and TensorFlow. Plus, with its small modular design, extending functionality, such as adding support for mixture of experts architectures, is totally feasible. Though not an official DeepSeek release, the community response has been overwhelmingly positive. On forums like Reddit, contributors praised its minimalist architecture, its resemblance to NanoGPT, and the freedom it gives to tinker and test without navigating massive code bases. That hobbyist spirit, embracing fast iteration and open collaboration, could shape future innovations in open-source AI. NanoVLM's evolution depends on community involvement. Developers are already proposing enhancements like dynamic batching and broader model compatibility. This mirrors how legendary tools like PyTorch and TensorFlow started, small-scale projects that scaled up through shared passion and contribution. In a world where AI often feels locked behind corporate walls, NanoVLM represents something different, a clear, accessible, and modifiable foundation that invites anyone to explore, build, and push boundaries. NanoVLM isn't just another open-source drop, it's a wake-up call. It proves that with a clear vision, smart architecture, and focused code, even a single developer can build something that rivals tools developed by entire teams. The performance speaks for itself. Matching the output of established engines like VLLM while using less memory, less complexity, and significantly fewer lines of code is no small feat. It opens up a new world where anyone with a decent GPU and curiosity can explore the inner workings of large language models. No advanced degree or enterprise hardware required. What's even more inspiring is how readable and extendable NanoVLM is. It invites developers to tweak, experiment, and improve upon it. Whether you're looking to understand tokenization, prompt handling, or caching mechanics, the source code acts like a live tutorial. In education, in research, or in solo dev projects, this kind of tool is pure gold. And the future? That's wide open. As more contributors explore its capabilities, we could see features like support for complex model types, dynamic batching, or real-time streaming added in. Just like PyTorch and TensorFlow started from small but strong beginnings, NanoVLM has the potential to grow into something transformative, built by a community, for the community. So if you're even a little curious about how large language models actually work under the hood, this might be the cleanest, fastest way to learn and build. If you found this breakdown useful, consider exploring NanoVLM yourself. And don't forget to like, comment, and subscribe. We've got more cutting-edge AI content coming your way very soon. Thanks for watching, and catch you in the next one.